everybody. My name is John Matthewson, and I'm part of the CAV trials team within National Highways. This morning, I'm going to talk to you more about the integration around connected and automated vehicles and how they're likely to interact with the strategic road network and other users on the network. So a little bit about me. I did a BEng in manufacturing and management engineering at Loughborough University, where I moved on to manufacturing launch of Range Rover Velar and the Jaguar XF, bringing the vehicles from verification prototype through to mass production, and then later on into developing JLR's, I guess, first autonomous pod type vehicle, termed Project Vector. There's a little link at the bottom left-hand corner. I'm not sure if you can click on that, but when the slides come out, it's worth a little Google. And then I left there, and I'm in the position where I am now as a senior technical advisor and project sponsor within the CAV team at National Highways. So a little bit about National Highways. So we are responsible at National Highways for all of the motorways and major A roads within England. We used to be Highways England, which I think describes us a little bit better. Yeah, so we're responsible for all of pretty much the network that you see there in the diagram. And although we're only about 3%, I believe, of the total road network in England, we carry something like 90% of the country's freight and miles driven. So although we're, I guess, small in length, we do carry a large proportion of the country's driven miles. So a little bit of an introduction into connected automated driving. The diagram here that you see is with the intention to separate or understand the two separate systems, basically. We often term CAVs, and we talk about CAVs as one unit. But actually, you can split them down into autonomous or automated vehicles and connected vehicles. And the reason why we want to keep this separate for the time being is we can deliver one or the other without the need for them both being developed at the same time. And as you can see, the natural progression will be towards connected automated vehicles, which in essence can do both, go further, drive longer. So connected vehicles for us at National Highways is mainly based around connected services. So these are services that use communication technologies, usually mobile networks, but there are two systems, two competing systems, in fact, ITSG5, which is a Wi-Fi based protocol, and then PC5, which is more of a 5G based network. But the idea is they do the same things, just in different ways. But the whole purpose is to communicate information to the driver that they wouldn't necessarily be able to receive without a connected device. So that's either communicating between vehicles, V2V, roadside infrastructure. So that's either us as a road operator and infrastructure owner communicating to them, or vice versa, or what we term V2X, which is everything from your calendars to your maps, to whether you're late to a meeting that you should have left for. And really the benefits to these in the future anyways is the reduction for new infrastructure requirements. So as we build new roads, new road signs, new VMSs at the side of the road, we do this to communicate with our customers, to advise them of of road incidents or such like. With the advent of connected services, this will allow us to solve a problem where some of our network is uncovered by road message signs. I live down just south of Bristol, and quite a bit between where I live and Bristol don't have any large message signs. The benefit of these connected services that we'll be able to communicate with anybody. These are not limited to new vehicles. It could be you on your mobile phone, on Google Maps, on Waze. And for us to have the ability to communicate, for example, that there is a stopped vehicle ahead of you, something that we would usually do with the road sign. But if we could get that into vehicles and enable us to essentially advise you that there is a stopped vehicle ahead, the idea is that you'll be aware earlier. And although there may be people around you that aren't connected, the more connectivity we can get into vehicles, people without connectivity will either want to join, or they see people around them slowing down, reacting to the message in which they've received, and act accordingly. And the other two that you can see there, obviously, I've covered active traffic communications, a little bit around where there's no gaps or no infrastructure, where there are gaps or no infrastructure installed, but also travel time dependability. If we can communicate with drivers and drivers can communicate with us, those active maps that people use in their cars or within their phones would allow us to give more accurate time for your journeys, but also active diversions. If we can communicate that we know there's a diversion ahead, such as roadworks, and the road will be closed. At the moment, we tend to give quite a wide margin, 10 till 6 in the morning, where these works may be completed. What we're attempting to do is to bring that much more granular and hopefully perhaps give an hour or two window between when a road will be closed and then we need to actively divert you. So connected services a little bit more. So this is starting to develop a lot quicker now within National Highways. We've just received funding to be able to get started with this. And the digital for customer strategy is what is going to deliver these connected services for National Highways. So they'll be aligned to obviously engagement with the customer, information provisions, be it dynamic speed limits, or say stop vehicle warnings, and really a large part of this is going to be our partnerships with OEMs or with map providers and information provision providers to be able to get an open flow of information around all of these companies. So it will be a phased approach. You won't get all of these services all at once. We'll pick, like you can see in the middle list there, variable speed limit information will probably be first, and moving through red X roadworks warnings. And what we want to do, although we're delivering these services in one umbrella, they will each require different requirements, different information, different data transfer. So each of those will be treated as their individual features, and we'll deliver them as individual features, but they will build part of our wider connected services. So this little nice, hopefully self-serving circle starts off with our customer, be it the actual vehicle, be it mobiles, sat navs, however it may be. Having that connectivity is really the first stage of that. The second part is getting output journey data and safety related data. So safety related data being perhaps heavy braking instances from vehicles, and then being able to communicate those in ways of queue detection and things like that. Then we do our part around connected services development, and that's where I talk about the individual service level requirements, and output those again back into the OEMs and the wayfinders, and that is how this information and services will be delivered to the customers. So there's a lot of words here, and I won't read through everything, but these are really the 5 main topics that we need to consider when we start delivering connected services. So other than safety, which is our first imperative, and is inherent in just delivering connected services, the customer is the second most important. And that's because if we try and deliver services, however good we think they are, that don't reflect what the customer wants, then we're in a position where we're just delivering something that won't get used. So identifying our customer requirements, the requirements of wayfinders and OEMs, because they are going to be the people displaying these messages and integrating the data of these messages, as well as other public road users. So we talk about the strategic road network, and a lot of people just consider that as motorways, but we do obtain the A road trunk road network as well. So there's other public road users that necessarily don't go on to motorways, but do use this trunk road that we need to consider. And the same with freight, logistics decisions, rerouting via roadworks, and alternative route planning is going to be important, as well as local authorities, because once people leave the network, we don't want people's services just to disappear. But for the time being, we need to ensure that our areas is the most fulfilled with and enriched in terms of data. So mapping as well. What are our delivery requirements for connected services? So do we know where our road asset locations are? Developing virtual boundaries. So this is for, say, roadworks warnings, delivering virtual boundaries. So people enter that virtual boundary and the message begins that, say, 1 mile ahead, there is a modification to the road network. And again, with lane accuracy, if you want to deliver services like emergency services warning, that there's emergency service coming up behind you, we need to give lane accuracy for that to those people to know which lane they are in and which lane the vehicle's coming up against. So technology, V2I, I2V, we've decided to deliver these service initially over cellular, being that it is an advice service and not an enforceable service, or the intention is not to enforce. We can deliver those either over mobile cellular networks, but we also need to ensure that there are gaps. We know there are gaps in the network, and how we go about filling those, as well as the operational technology side. What do the operations centres that are really the backbone of national highways managing the network, what do they need to manage, receive and send these messages? In terms of data, cybersecurity, ensuring these messages aren't modified in the air and are received or malintention used against them, but also the latency and accuracy of these messages. There's no point in us delivering these messages 5 minutes late, and people have already gone through this, the area in which the message we're trying to send. And how do we manage all of this data? How do we choose which data to use, store, transfer, as well as collaborate with our own internal systems, but also consider systems outside of our own control, like local authorities? And finally, regulation and legislation. CITS services such as CV2X and ITS-G5 do have standards. So it will be obviously essential to use these, but we have our own standards. The DMRB, design manual for roads and bridges, ensure that our own requirements and standards are up to date. So that's a quick, I say a quick overview of the connected side of things. So you saw the little diagram. We're going to just touch on the automated and autonomous vehicles. So you may hear automated, autonomous, self-driving. Essentially, they're all the same thing. They're just at different levels of control, essentially. So an automated vehicle, one that can perform the driving function that is usually completed by a human, by the ability to sense its surroundings and make decisions based on those surroundings. There are actually 5 levels of automation. There are actually 6. So level 0, 1, 2, and then up to 5. I've taken out the lower ones as they're things like cruise control and AB that we already have really in most of the cars that you see now. The first level that we're really going to see shortly is the highly automated level 3 system, where the vehicle completes steering, acceleration and braking and monitoring the environment. But at the end of the day, the driver is still responsible for being ready to take back control. So what are the benefits? Safety is probably a huge factor in this. Reduction in collisions, even basic driver assistance like AEB, considerably reduce the amount of killed and seriously injured on the road. So as we go more automated, we can take out some of those human error, attention type collisions, and give the vehicle more control. And as you can see there, by 2030, there's an expectation that serious collisions will be quite considerably reduced, and obviously life saves, but also the financial impact, as you can see from traffic emissions. If we can reduce congestion, reduce accidents, inherently that's going to improve the traffic emissions, individual vehicle emissions. Obviously some will be done by electric vehicle and the increase of electric vehicles, but I think it's going to be a larger crossover where we'll have a mixed fleet for those, and also improving travel time. You reduce the incidents, you reduce the congestion, you can reduce people's journey time, but also with the increased amount of autonomy, you'll have people being able to be more productive and working on the go whilst in their vehicles. So I hope this works. There won't be any
sorry
sound,
to cut in, John.
Yeah,
time's up, so if you could just wrap up very quickly.
Of course. So I will skip on from this then. So I just want to give you a quick overview of preparation for automation. So where we look at this, we identified infrastructure-based factors that are relevant to national highways that will stop automated vehicles staying within their automated features. The 3 main ones around lane detection, construction zones, and road surface conditions, although this is not really something we can control. So we picked the geometric configuration. So we completed a project called Caviar, which identified using simulation and real life data which of these infrastructure-based disengagements were relevant, and how we could go about modifying either engineering or policy or the actual road network to help CAVs navigate the network better. So apologies for the whistle stop tour, but I'm just going to bring back to this image here and then add on cooperative. So we've done autonomous, connected, becoming connected and automated. But once we move on in the near future, we're going to be looking at cooperative connected vehicles. And that are those that communicate with each other and act almost as one swarm. So the concertina effect that you get with accidents and traffic congestion rather than people slowing down, stopping, and then there's a reaction time. These will be able to act as one, really. So I'll end it there. I think there's a few questions, so I think we'll tackle those, Stephen.
Right, Glenn asks, are there any V2V, V2I and V2X interface standards available now and specified as mandatory?
No.
Okay.
So there are data standards that we use for the actual message standard. So to ensure that the message we send is known by whoever is receiving it. There are standards for that. There aren't necessarily standards for showing messages. So we obviously have specific standards for physical roadside infrastructure. But at the moment, there aren't any standards for how a vehicle or how Google or anybody else will actually show that message, how big it needs to be, what color it needs to be. So one of the projects that's going on within Europe is looking at whether we need to standardize those visual messages to ensure everybody receives them and can see, essentially can see them.
Right, thanks. Yeah, so we've only got
Yeah,
2 minutes left for questions. So some
Yeah,
quick fire answers, if you would, please, John.
Yeah, go
Will
on.
this technology be an add-on to existing vehicles, or is it only for new vehicles?
So we're hoping it's going to be an add-on. So Google,
Okay.
whether you use your phone or Android Auto or CarPlay, it should be integratable with the vehicle.
Excellent, thank you. So what are the mitigation strategies used to avoid driver distraction and information overload?
Very good question. There are human interface projects going on for driver distraction. So it's not just these messages, there's other messages that aren't related to connected services, with people wanting more messages or less messages, but not being able to choose which ones they are. So there are projects going on, and it is a problem that is being recognised, certainly within the automotive industry.
Okay, and I don't know if there's quick answers possible to this, but Matthew asks, what elements of systems engineering are used at national highways?
Very good question. I think probably a follow-up. It's probably more within our data area and our digital services than where we're looking at the moment. We're not as far down the line with systems engineering as probably some are with this. So it's one to follow up, I think.
But it's something that you are advocating for and see as valuable.
Absolutely. A standardized way of being able to develop and introduce all of this. It's really the only way that we're going to be able to do something of this size.
Okay, great, thank you. So there was